to this talk on the Windows Azure platform. It's great to be here, isn't it? I love Tech Ed. Tech Ed is always fun. Who has been to Tech Ed before? I'm curious. Who's been here before? Oh, gee, maybe only fewer than half of you. Well, for a lot of you, it's new then. Great, welcome. It's always such a pleasure to have the after lunch slot when people's minds are fresh and all the blood is in their, well, stomach, actually. It's a challenge. My goal here this afternoon is the following. It is to give you a big, broad intro to this thing called the Windows Azure platform. I would argue, no, I believe that there are three things you can learn about with a new technology. What it is, how to use it, and why you should care. There are many, many sessions here at Tech Ed about how to use this thing. This is not one of them. This talk is entirely about what this platform is and why you should care. As a result, you're going to see not one single demo. You're going to see all kinds of pictures. Because my idea here, my goal, is to have you walk out of here with a very clear sense of what the components are in this broad platform, what they do, and how you might use them. In fact, broken down just a bit more, we actually have two goals. I want to first describe the Azure platform. I then want to talk about scenarios, typical scenarios in which you would use the Windows Azure platform. Before we do any of that, however, a little tiny bit of background. Cloud computing. That phrase is so darn blurry. What it means depends on who you're talking to. I'd like to suggest a way to think about it. First of all, this conference has many sessions on private cloud. Very interesting technology, not our topic here. Whenever I say cloud computing in this session, I always mean public cloud. And that means software run on computers in data centers owned by, in this case, Microsoft, in general, Amazon, Google, other vendors, accessed via the internet. Public cloud. That's where we are in this talk. When you think about public cloud technology, I think it's really useful to divide public cloud technology into two big, broad categories. Number one, cloud applications, commonly called software as a service, SaaS. Cloud apps are what they sound like. They're apps that run in the cloud. Email, CRM, SharePoint. They're used by you, me, your mom. They're apps. Category number two, cloud platforms. Cloud platforms are things in the cloud on which developers, like many of you, can write new applications. They're used by developers, not by your mom, unless your mom was a developer. I'm curious. Is anybody's mom a developer? No? No? No second-generation geeks in the room. Yeah, okay. That's all right. I find that sometimes. So, our topic here is not cloud apps. In the Microsoft world, that's things like BPOS today, Office 365 tomorrow, Dynamics CRM Online. Those are cloud apps. We're talking about cloud platforms, public cloud platforms. In the Microsoft world, the primary story for public cloud platforms is the Windows Azure platform. And let me just stop right here. I've spent much of the last 2.5, 3 years flying around the world talking to people about Windows Azure and cloud platforms in the broad sense. And here's what I have come to believe. I've come to believe that we are at the beginning of what will be a relatively slow, but nonetheless unavoidable, inescapable transition to a new world. Here's what's happening. Think about how many times in our industry's history we have seen new kinds of platforms, hardware platform styles, emerge for business computing. Let's count. There are lots of ways to think about this. This is my favorite. There were mainframes in the 60s. There were mini computers in the 70s. In the 80s, there was lots of change. PCs appeared, and then PC-based servers, Intel-based servers appeared. In the last decade, I would argue that mobile phones are a big platform. So what is that? Mainframes, minis, PCs, servers, mobile phones. 5 platforms. I believe that with cloud platforms, we're seeing the rise of the sixth platform type. New platforms do not wipe out the old ones. People did not move mainframe apps to the PC client-server world, for the most part. No, what you do is you build new apps there. 10 years from now, I would posit that cloud platforms will be the home of a very large share of our apps. I think this is important. I think this matters a lot. And so in the Microsoft world, that story boils down to Windows Azure. Let's talk about this thing. The Windows Azure platform has a bunch of different parts. The foundation, unsurprisingly, is Windows Azure itself. There's also SQL Azure, which, as you might guess, does relational data and more. There's this thing called Windows Azure App Fabric, which essentially is a lot of infrastructure for building various kinds of apps. All of this is designed to support cloud applications and data in the cloud, and we'll see sometimes on-premises as well. Quick terminology note. That word on-premises. I'd never heard that word before the arrival of cloud computing. All on-premises means is not in the cloud. So stuff in your data center, your laptop, those are all on-premises. That's what that means. It means non-cloud. So these guys are all about supporting apps and data that run in the cloud, and in some cases, we'll see, also apps that run on-premises. The fourth piece is this guy called Windows Azure Marketplace, which is what it sounds like. It's a store, it's a marketplace to help you find applications and data and more in the cloud. I'm going to spend the next chunk of time here, most of this session actually, walking through those four colored boxes and telling you what each one does. And I'm going to start, unsurprisingly, with the foundation, the thing that gives its name to the entire platform, Windows Azure. Windows Azure, again, supports apps and data, not relational data. Relational data is SQL Azure's piece of this puzzle. We'll see what kinds of data Windows Azure supports. It does that by providing a compute service, a storage service, both of which run on large numbers of machines in Microsoft data centers scattered around the world, about which I'll say more in a little while. Those machines and the software they run in each data center are managed by an application called the Fabric Controller. Piece of software is a better word than application, but by software called the Fabric Controller. There's also something called a CDN, which usually stands for Content Distribution Network, and there's this thing called Connect, which helps you connect that into your on-premises world. I'm going to walk through all five of those gray components right now. And I'm going to start with compute, because that's the thing that is the foundation for logic, the core thing we're doing on Windows Azure. You might think that Windows Azure would just take ordinary, standard, stock, vanilla Windows Server and run it on Microsoft servers in the cloud. And I suppose Microsoft could have done that, but it wouldn't make much sense. It's not what they do. Rather, Windows Azure actually runs a version of Windows Server, effectively. They call it Guest OS. It looks to you like Windows Server, but not exactly. It's not exactly the vanilla on-premises Windows Server environment for some very good reasons. Here's how this works. In Windows Azure, you have these things called roles. There is, for example, a web role. A web role is a pre-configured setup that includes IIS, Microsoft's web server, and is designed to run web applications, hence the name web role. There's also something called worker roles. Worker roles are just pretty much Windows. There's no pre-configured IIS. Those two roles are by far the most commonly used today. So, for example, if I want to build a web application, ordinary web app with, let's say, ASP.NET, I can build that app, I can then deploy it into a web role, and I can run it. Web roles run standard ASP. Or I might use WCF, or I might use PHP. I can even, if I want to, install in a worker role Tomcat. It's Windows, right? I am not committed to just use .NET technologies by any means. The point here is, the key point is, when I run my app is actually running in some number of virtual machines, as my slide shows. My app is running in VMs. Because when I give my app to Azure, I do not do this. I do not say, Azure, please give me a VM. And then I install my app in the VM. Azure, give me a second VM. That's not how it works. When I give an app to Azure, I say, Azure, here's my app. Please run my app. And I have told Azure what my web roles are, what my worker roles are, if any. I then say to Azure, hey, Azure, please run, let's say, 3 web role instances, and how about 2 worker role instances? Azure, actually the Fabric controller, then spins up 3 VMs and runs my app in the web role piece, 2 more VMs, runs my worker role part, and keeps it going. I do not tell Azure to give me a VM directly. I give Azure my app. I define what I want, number of instances, and it just spins them up. Azure is often characterized as what's called PaaS, Platform as a Service. In contrast to technologies like Amazon Web Services, EC2, which is Infrastructure as a Service, IaaS. In EC2, you say, give me a VM, and you manage the VM yourself. In Azure, you say, here's my app, run my app. And the infrastructure, the foundation is already there. You'll see that notion of PaaS, that dedication to PaaS runs throughout the platform. The platform is PaaS in all of its technologies. We'll see this over and over. The notion is that you don't have to manage this stuff. You give it your app, you give it your data, we'll see later, it just does things. This is a primary reason why this is not vanilla Windows Server. They're trying to reduce the management costs and make life simpler and cheaper for all of us. Why would I divide an app into web roles and worker roles? I might not. I might very well have an app that just web roles, just takes web requests and that's it, ASP. But I might also have an app where I've got web roles on the front that accept user requests and pass them to worker roles in the back to process. Apps that divide that way scale much better. So it might be the case that I choose to do that. I can then also scale by increasing or decreasing the number of web role and or worker role instances. If I have lots of users, I can up the number. If I have fewer, I can shrink the number. Since, as we'll see, Azure charges per VM per hour, per instance per hour, it matters how much you run there. There is, however, at the moment, no auto-scaling. You must do it yourself, either in code through APIs or interactively through a console. So you can do it yourself. Finally, there's one more kind of role as well. There are VM roles. VM roles are different. VM roles, as the name suggests, let you upload a Windows Server 2008 R2 VHD image, and they run it. They run it. So you might think, well, okay, so that means I can take existing Windows Server apps and run them up here unchanged. And the answer is, yeah, you probably can, at least in some cases. But be careful about that, because let me tell you some things. The way Windows Azure works, to get the service level agreement, the SLA of Azure, you are required to always run at least 2 instances of every role. You're required to. And Windows Azure will automatically load balance all requests it receives for a given role across all the instances. It has no notion of sticky sessions. So you must have instances that are stateless, that are interchangeable virtually, almost all the time. There are a couple exceptions, but in general, you build instances that are interchangeable. If I take an existing Windows Server app, which maintains state locally, runs as a single instance, and put it in a VM role, I can do that, but it's not going to run very well. Look at the SLA. So don't think of Azure as being primarily about taking my current Windows Server apps, moving them unchanged to the cloud. You can do that sometimes with more or less effort, but I would argue that is not the primary goal. Think of Windows Azure as being more about a platform for building new apps or for extending existing apps into the cloud. It's Windows up there. You can use your conventional Windows skills, Visual Studio, all the things you know. But there are differences as well in how you build the apps. And those differences stem from the desire of Azure's creators to be a new kind of platform that scales better, that is more reliable, that is cheaper to administer. Great. Next, Windows Azure Storage. 3 options here. Number 1, blobs. Blob, as you might know, is an acronym for binary large object. Blobs are what they sound like. They're big chunks of bytes in which I can store videos or audio or pictures or anything I want. Very simple, unstructured binary storage. Number 2, tables. If I ruled the world, the first thing I would do before imposing world peace is make Microsoft change the name of Windows Azure Tables. I feel strongly about this because tables is just a deeply misleading name. These are not tables. They're not relational tables. What these are is a massively scalable, essentially key value store designed to give you fast access to large amounts of data. If you are familiar with the NoSQL movement, who's heard of NoSQL? Well, a lot of you, right. NoSQL is actually an acronym. It doesn't mean no SQL. It means not only SQL. There are scenarios for which SQL databases just don't work effectively. And one of them is massive amounts of data that require speedy access. Well, that's what tables are for. Tables are for pretty special scenarios about massive data access. It's not the only case where they're useful, but it's a primary case where they're useful. It's what they're designed for. Because web-based apps are going to have giant data potentially. And so that's why this is in here. If you look at other vendors' cloud platforms, Amazon, Google, they pretty much all have a technology like this. A NoSQL, massively scalable solution. That's what tables are. Don't be confused by the name. And the third option is queues. I know, queues aren't storage, are they? But nonetheless, queues are in Windows Azure Storage because that's where they're implemented. Queues are what they sound like. They are a way to communicate via messages. And perhaps the most important way queues are used today is to let web role instances talk to worker role instances. They talk via queues most often. So there you have it, the 3 options for Windows Azure Storage. You know, in some ways, I think of Windows Azure as being like an operating system, and this is like the file system. If I want relational data, that's SQL Azure coming up soon. This is more like the file system, except it's cloud-based. Now, speaking of file systems, there's an interesting option called Windows Azure Drives. With Windows Azure Drives, I can take the file system in an instance, a web role or worker role instance, and I can effectively map that file system to a blob. So, when I write to the file system, that data is stored in a blob persistently. Interesting. If I don't do that, if I just write to the file system on my local VM, my local instance, that data is not persistent because instances come and go, as we're going to see right now. Next, the Fabric Controller. The Fabric Controller, I told you before that Windows Azure data centers have lots of machines, and that those machines are controlled by this software called the Fabric Controller. The Fabric Controller utterly owns all the Windows Azure machines in a given data center. It owns their power switches. It owns the network switches. It owns the racks. It owns the entire environment. It is God in the Windows Azure domain, in that world. So what does it do? It does a lot of things. One thing it does is when you give Windows Azure an app and say, Azure, run my app. I told you that Azure creates VMs for you. Well, the Fabric Controller decides where those go because every machine is running a Fabric agent with which the controller communicates. This lets the Fabric controller intelligently place new instances and thus achieve very high utilization of those machines. Hey, by the way, I earlier asserted that public cloud platforms like Azure are going to be huge in the future. This is one reason why. It's because they can achieve such high utilization of the hardware they use, they can be much cheaper than in-house data centers. They also, because people like Microsoft buy in such bulk, can get great price discounts on hardware. Again, much cheaper. Pretty much all the analyses from all kinds of organizations, Microsoft and others, have made this point clearly, that public cloud data centers, via economies of scale, intelligent software, and more, over time are going to offer price advantages that dwarf what we pay for on-premises data centers today. Tomorrow, will this be true? In a year? Probably not. In 10 years? Absolutely. And so, over time, I expect this transformation to happen, in no small part for economic reasons. Not entirely, but in no small part. So the Fabric controller is able to deploy instances in ways that make good sense based on the load on the computers it owns. But it does more than this, too. Remember I told you earlier that when you give Azure an app, you say, Azure, run my app, and I would like, let's say, 3 web role instances and 2 worker role instances. The Fabric controller will start those for you and then monitor them. If one of them fails, if the VM crashes, if your app fails, the machine it's running on fails, the Fabric controller will notice and will start a new one. It starts a new one. So you've told it, I want 3 of these and 2 of those. It will always make sure there are 3 of these and 2 of those. Now, sometimes one might fail, so it'll be down for a while, but it'll start a new one. Even better, the Fabric controller also does updates for you. It patches Windows on both underlying hardware and the VMs you're running in, for web and worker role, not for VM role. It patches Windows. And so what that means is your apps need not be taken down for patches to the system. Your apps can run forever. How does it do this? The answer is it knows that you always are running at least 2 instances of each role. Remember I told you you had to do that? It knows this. It will shut them down one at a time. Patch the system, start it again. Shut the other one down. Patch the system, start it again. This is why you have to run at least 2 instances, because the controller will patch things beneath you. You can actually stop this if you want to, but that's the default behavior. A big goal here is to make apps run forever, make apps that run forever, and to make it so that you don't have to pay the price of human labor to do these kinds of updates. They're trying to make apps more reliable and cheaper to administer. It's a primary goal of the Fabric controller and of Azure as a whole. Next, the CDN. Here's the problem. Suppose I have data in blobs in Windows Azure. Maybe it's videos, for example. Maybe I'm an online video site. And I have people using that data from all around the world. Well, Azure has, as we'll see in a moment, 6 data centers scattered around the world right now. But still, if everybody had to go to a given data center, it might be kind of slow. So it's common today to instead use a CDN to do this. There are plenty of CDNs in the world. Azure has one now, too. Here's how it works. The notion is that the CDN has many points of presence around the world. Not just the 6 Azure data centers, many others. So, for example, a user in South America might go to access, let's say, a movie stored in some blob. Well, chances are the first user to access that movie will copy the data from a North America data center. But that data can then be cached in South America, let's say, in one of the CDN's points. Later users in South America will then access that cached copy, not go all the way back to the data center in the US to get it. The idea is to speed up access to frequently accessed data. And today it works for blobs. Microsoft tells us that will expand over time. So CDNs are interesting and useful for some kinds of problems. The last piece of Windows Azure itself is also interesting and useful for some kinds of problems. It's this thing called Connect. Here's the idea. Suppose I have applications running, some role instances in Azure, and I want to connect to them from an on-premises Windows machine. That machine might have on it applications, data, that I want to link in some way to the instances, to the app, running on Windows Azure. So how do I do that? Well, the option that Connect gives you is this. You can install on that computer this thing called an endpoint agent. It's software installed on that machine. That endpoint agent can then configure an IPsec tunnel to Windows Azure. Set it up for you effectively. Once you do this, you are able to do interesting things, like make the application on Azure look like it's in your domain, and thus give the user single sign-on, the Azure app. Or, the reverse problem, you can let the Azure app see on-premises data as if it were local. So for example, if I've got my logic running on Azure, and I want the app to access a SQL Server database on-premises on that machine, Connect lets me do that with the very same connection string I'd always use. It looks like it's in the same network. Now, this is not a full-fledged VPN, although Microsoft tells us they'll give us that at some point. But it's a way to achieve many of the same things on a per machine, a per server basis. So, there are the 5 main parts of Windows Azure itself. It's worth talking a little bit, though, before we go to SQL Azure, about the data centers. Because to grasp what's happening with Azure, it's important to have a picture in your head of this data center structure. Because that's where your app is running. That's what the cloud means in the most concrete, literal sense. So, as I said earlier, Azure has 6 data centers, 2 in the US, 2 in Europe, 2 in Asia. When you give Azure your app, you tell it which data center or data centers you want it to run in. You tell Azure where to run the app. If you are running your app in more than one data center, you might want to take advantage of this relatively new thing called Windows Azure Traffic Manager. It's in CTP right now. This guy, Traffic Manager, is able to distribute requests from users based on policies you define to let those users see better performance or higher availability, or to spread the load across data centers. It looks like this. There are 2 data centers in the US, there are 2 in Europe, and there are 2 in Asia at the moment. Suppose you build a Windows Azure app, and you deploy that app with instances in all 6 data centers. That's hardcore. You might do that because you've got global users. You want to give them all good response time. Okay? You don't have to do this to do that, but you might do it for that reason. This is an extreme example, but makes the point. I've got all these users around the world. I need some way to very clearly and intelligently control which instance they go to. In general, I probably don't want users in Singapore going to a European data center. So, Traffic Manager can sit in the middle here. You can define policies that route those users to the right data center based on their locality, based on data center loads, based on time. If one of them goes down entirely, you can route around it. So, that's what Traffic Manager is all about. So there it is, Windows Azure itself. Let's talk next about SQL Azure. SQL Azure is, to a great extent, really, really simple to understand. Because to a great extent, SQL Azure is just SQL Server, a subset, a large subset of SQL Server in the cloud. It looks like this. I have SQL Azure Database, which stores relational data and looks like SQL Server to me. I have SQL Azure Reporting built on top of that, and I have SQL Azure Data Sync. SQL Azure Reporting is what it sounds like. It's a subset of the on-premises reporting services designed to work on cloud data. SQL Azure Data Sync I will describe in just a minute, but let's first talk about SQL Azure Database. Again, conceptually, it's really simple to understand. You have, in the cloud, a server through which you can create regular SQL Server databases. You access that thing via TDS, the same protocol that you use to access data on premises. It looks like SQL Server. But don't be confused. Although I have a box labeled server, don't for a minute think that you actually have your own instance of SQL Server itself up there. You do not. It's a virtual server. Behind the scenes, there's a lot going on. Again, this is a platform as a service approach. You're not just running some database instance in a VM that you've got to manage. No, no, no. This is a service up there. You talk to it, you say, give me a database, it creates it. You don't manage the database instance. It is a service. This is the hallmark of Microsoft's cloud platform. It takes this PaaS approach across everything. So, it's a virtual server behind which you can create ordinary databases. SQL Server, and in fact, SQL Azure, and in fact, Windows Azure as well, replicate all data they store. There are, by default, 3 copies of each database stored. And in fact, there are 3 copies of each blob, table, and queue in Windows Azure. Data is replicated. And so a chunk of what you do on premises, lots of the admin, for example, just goes away. It's one of the big pluses of this approach. Okay, let's stop here again. A big plus of this approach is you get in the cloud for not too much money, as we'll see later on, reliable, replicated storage with low administration. What's a drawback of doing this? In fact, let's step back. What is the biggest objection that most people have to cloud platforms in general? It is some flavor of the following. People say, you want me to put my mission-critical data in data centers owned by Microsoft, accessed via the internet, scattered around the world. Are you out of your mind? I hear this all the time doing talks on cloud platforms. People say, you must be nuts. We're never going to do this. And so here's a perspective on that. Here's how I see this. First of all, when people look at this, they tend to think immediately about their most critical mission data. They think, oh, put my ERP system in the cloud? What? Don't do that. Don't do that. The reality is that organizations tend to have a continuum of data security needs. Over here is stuff that is absolutely mission critical, very secure. That may never go in the public cloud. Over here, though, are things that are less so. So, for example, with a public sector organization, many governments have data they're required by law to make public, like census data. Start over here. People in their mind share start over here often. I'll never do that, and maybe you won't. But starting more over here, I think, can be a good solution. Another way to approach this is to realize that it's plausible to put some processing in the cloud and leave data on premises. That's quite common, actually, among Azure users today. And one more perspective here. We face issues like this all the time in our world and our economy, where new approaches arise that have some risks. Over time, if the thing we're trying to learn how to trust proves trustworthy, and in fact offers benefits like lower cost, we can learn to trust. There are so many examples. One of my favorites is manufacturing in China. If you told me 30 years ago that today half the world's stuff would be manufactured in communist China, I would have laughed you out of the room. But today, we learned to trust over 30 years, and the benefits were significant in terms of low cost. Building software in India. If you told me when I was a graduate student that places like Bangalore would become giant software centers, I would have said, you're crazy. But we learned to trust because developers were great and they were relatively cheap. Even with the cloud, the most successful cloud application so far, arguably, business application, has been CRM. Well, what is in CRM? Gee, sales leads, sales projections, pipelines, fairly important stuff. People learn to trust. So, I would encourage you not to view the data issues in the cloud as a showstopper. I don't believe they are. We can learn to trust over time as we have with so many other things. Now, of course, the benefits have to be there, and the cloud providers must prove trustworthy. Does that mean perfect? No. They will not be perfect. But it means at least as good as our own data centers. At least as good. One caveat about that. Many countries, many industries have laws, they have regulations that constrain what you can do with data. For example, I was in Germany last month. In Germany, there's all these tight laws about various kinds of data that cannot, by law, be stored outside German borders. Well, that's tough because for Azure, other cloud platforms, there are no data centers in Germany. So, things like that, things like HIPAA, regulatory issues, they can be showstoppers, at least today. So let's be real about this. But I think the generalized fear people have is not a showstopper. It's more about building trust over time, making this change happen slowly through reliability, which we hope is there over time, and advantages such as lower cost. All right. SQL Azure Database lets you store relational data in the sky. SQL Azure Data Sync says this. It says, you know, suppose I have some data in SQL Azure Database. Suppose I have an application running on Windows Azure, which is deployed in data center. Sound people? My mic keeps cutting off, does it not, sound people? Can we fix this? No one is responding. Well, we have data centers around the world. If you're deployed in 2 of them, and I have SQL Azure data the app is using, it may well be the case that I want to keep that data synchronized. That is one of the scenarios for which SQL Azure Data Sync makes sense. It's configuration driven. You don't write code. You configure stuff. And if you do that, you can keep databases in sync between different Windows Azure data centers. And that's useful for apps deployed in that global way. It's also possible to use this to synchronize Windows SQL Azure data with SQL Server data on premises. Another useful thing to do. So that's what this guy's about. And again, it's configuration driven. It's not about writing code. You just configure things to do synchronization. Next, Windows Azure App Fabric. Okay. Application infrastructure in the cloud. What we're seeing here is a variety of things all running on Windows Azure. Right now, Windows Azure App Fabric has 3 things: Service Bus, access control, caching. There's more that's been announced in CTP very soon, but right now, those are the 3 parts of the story we're going to talk about. I got to tell you a couple things. These 3 technologies are wholly disjoint from each other. They solve different problems. They're all interesting. They're all potentially useful. But they're all lumped together because they're all infrastructure. So it's almost more accurate to think of App Fabric as a brand that just means support for applications. And do not for a second confuse App Fabric with the Windows Azure Fabric. Those are totally separate concepts. They both use the word fabric, which is kind of a shame, but naming is hard. Naming is really hard. So, you may have heard this before, so forgive me. I spent a long time being very critical of how Microsoft names its products. I was just so critical. Stupid name, dumb name, why did you do that? And then one day, a while ago, they called my bluff. They hired me to help them name something. And they brought me in, and within 20 minutes, I promised I would never again criticize their naming, because it is a very hard problem. All the good names are taken. All the bad names are taken. It's a very hard problem. So, Windows Azure App Fabric, great name. I love the name. It's a really hard problem. Anyway, think of those three things as almost disjoint technologies. They solve individual problems. They're all interesting, all important, but they're not unified in the way the parts of SQL Azure are, for example. One more thing. There is also a set of technologies called SQL Server App Fabric, which are the analogous things for the on-premises world, SQL Server. Now, it turns out some of these guys, Service Bus, Access Control, don't have analogies on premises, but caching does. Other things do as well. Microsoft tells us that going forward, they will do things cloud first. They'll build in the cloud first, then on premises. And we're seeing that already, which is really interesting. So let's walk through these three things. First, Service Bus. Here's the problem. Suppose I have an application running on premises behind my firewall that exposes a service built with Windows Communication Foundation, WCF. Suppose further that I want to have a client in some other organization access that service. The client is on premises and the cloud, doesn't matter. But that WCF service is behind a firewall. How do I do this? Well, on the face of it, it can seem like a very simple problem. But it's not. It's not, because for one thing, organizations frequently today use network address translation, NAT, which means that server has no fixed IP address to expose to the outside world for the client to use. Second, it's behind a firewall. If I ask my network admin to open that port in the firewall, what will they say? They will say, get out of my office, right? You can't do it. So the problem is not so simple. Have you heard this? There is a maxim that says that in computer science, we can solve any problem by adding one more level of indirection. That's what happens here. Service Bus runs in the cloud and adds a level of indirection to help solve this problem. And here's how it works. The service registers its endpoint with a registry, a simple directory service, in Service Bus. Service Bus then exposes the very same endpoint, the very same one, a SOAP, or more likely these days, a RESTful service. A client can then look up this endpoint in the registry. When you get access to Service Bus, it gives you a URI base. You can use it for a namespace. You give that name to the client for this service. The client looks it up. The client then invokes the service in Service Bus, which has a fixed IP address. Service Bus then makes that same invocation back on your service. Great. Obvious question. How does this solve the problem? In particular, how does step 5 work? How does step 5 work? Here's the answer. The answer is that when the service in step 1 registers its endpoint with Service Bus, it opens a TCP connection to Service Bus running in the cloud, and it leaves that connection open. When step 5 happens, the firewall sees that request as inbound traffic on an outbound TCP connection. It's already open. The firewall says, fine, no problem, and passes it through. That's how it works. You may think, oh man, this is a really picky, detailed issue. And it is for some people. But for others, it's really important. I did an event in London a while ago with the chief architect from EasyJet. And he was adamant to me, he was maniacal, that Service Bus was the most important component in the Windows Azure platform. Because he and his organization has all these services they want to expose, reservations and so on, to devices and kiosks and things all around the world. It was great for them. So if you have this problem, it's a great solution. Now recognize this is wholly disjoint from things like SQL Azure and Windows Azure. It runs on Azure, Windows Azure, but the problem it solves is different. And the problem it solves is getting broader as well. There's a CTP right now for a version of this that has in Service Bus queues, where you can do queued communication, and not just that, it has a publish and subscribe mechanism, a pub sub way to have topics, subscribe to topics. If you've been in the Microsoft world for a while, you know that Microsoft has never actually shipped a real pub sub technology. We're finally going to see one, which is really cool. All right, there's Service Bus. Next, access control. Again, this solves a problem that's important and interesting, but disjoint in many ways from the others. This technology runs on top of Windows Azure. Here's what it does. Suppose you've built an application that runs in the cloud, in your data center, at a host, doesn't matter where it runs, just runs somewhere, okay? It's a web app. And you want to let users from browsers access your app across the public internet. Great. You now need to have some way, probably, for those users to log in. Everyone wants to know who their users are. So how do you do this? Well, obvious possible answer is to create a database of login names and passwords. Everyone does this, right? But it's a huge pain. You got to maintain all that stuff. It's a huge pain. So there is a pretty strong trend today toward outsourcing identity, towards saying, you know what, user? Don't log into me. I instead want you to give me an identity from some other identity provider, some other IDP. Give me a Facebook login. Give me a login from Windows Live ID or Google or OpenID or even a corporate login from Active Directory, which can be exposed via this thing called ADFS 2.0. More and more applications are saying, user, don't log into me. I do not want to maintain login names, passwords. I just trust people like Facebook or others to maintain that stuff for me, and I'll take their data from you. We're seeing more and more of this. So the user at the browser can access the app, and the app says, go get a login, go log into your IDP. It might do this via a button to click on or a browser redirect, whatever, okay? But somehow the user then goes and authenticates, they log in, and they get back this bunch of bytes, let's call it a token, from the IDP. In here is stuff like their name and other things about them. With me so far? Now, it is entirely possible that the user via the browser can submit that IDP token to the app. And if the app accepts only, let's say, Facebook logins, that's straightforward. But more and more, apps want to accept multiple IDPs. Apps want to make it easy for users to use them. And so an app might say, you know, you can log in with Facebook, or with Google, or Windows Live ID, or with various things. It's good for users, but it's painful for developers because all those IDPs have different token formats, they have different contents in different styles. It's a huge pain for the app developer to deal with all those different IDPs. Aha. Remember that principle from the last slide? Any problem in computer science can be solved by adding one more level of indirection. Great. Windows Azure Access Control, Windows Azure App Fabric Access Control, is another level of indirection. It runs in the cloud. It runs on Windows Azure. And it runs, of course, as a service. You don't configure it. It's just there. You can use it. In this process, if access control is involved, once the browser gets the IDP token, it passes it off to access control. Access control validates that this is in fact a legitimate token from that IDP. It then creates a new token. Let's call it an AC token, according to rules defined for the application we're talking to. Every app can define its own set of rules and access control about how this transformation should take place. There's a rules engine. Access control then spits back the token, which the browser sends to the app. The app then processes and uses the data in this token. Why is that better? Two big reasons. Number one, the app only has to deal with one kind of token. All it ever sees are these AC tokens. Doesn't see anything else. Number two, what's in that AC token can be standardized. So no matter what IDP the user uses, via access control, the rules engine, the token the app sees can be the same, with the same contents. The whole point here is to make it possible for apps to accept logins from diverse IDPs without suffering too much pain. Finally, the third thing, caching. Caching is really simple, conceptually. This guy actually is an addition for Windows Azure applications. The notion here is this. Applications cache data locally, but as you recall, in Windows Azure, there are no sticky sessions, which means there's no way for a client to always go to the same instance of your app. Instead, with App Fabric caching, there's a caching service that runs as a service and lets your instances, your Windows Azure instances, cache data back there and access it from that cache. It's analogous to Memcache, Oracle Coherence, except it runs in the cloud and it's a service. You don't have to install it, configure it, manage it. It's a service done for you. It's the PaaS approach to caching in the cloud. And finally, the last parts of Windows Azure itself, the marketplace. Two pieces, data market, app market. Easy to understand. App market is what it sounds like. It's an online marketplace you can go to find cloud applications, finished apps, or components for building cloud applications, or potentially others, or even training or consulting services. It's actually broader than just apps despite its name. So, a fairly familiar idea expressed on top of the Windows Azure world. Windows Azure Data Market is arguably more innovative. Here's the idea. There are plenty of companies in the world that make their living by selling data. But there is no single centralized marketplace to which consumers of that data can go to find data sets that they need. It is the goal of Windows Azure Data Market to be that marketplace. And here's how it works at a high level. On Windows Azure Data Market, content providers, people who own data they want to sell, can store that data in Windows Azure or at their own sites. You don't have to store the data in Windows Azure. You can. Data Market then provides an app called the Service Explorer that lets you go to Data Market and look around. What's there? What data sets are there? What can I do? You learn about them. You can then actually buy ones you want and build applications that via Data Market access that data. That access is via ordinary REST or, even better, through OData. Who knows what OData is? I'm curious. A few of you. OData is very cool. OData is this emerging standard protocol for doing diverse kinds of data access around the web and elsewhere. Worth understanding, I think. So OData is how you can access data in this data market. It's interesting. A marketplace for buying, trying, and then accessing commercial data sets. You might say to yourself, well, I'm a developer, if you are. I write code. I don't care about things like pricing. Well, you know what? With cloud platforms, trust me, you care about things like pricing. And the reason is that Windows Azure, like most cloud platforms today, has a usage-based pricing model. So you can build an app that runs very cheaply, build an app that runs in a very expensive way. Just as today we design apps to perform well, to scale well, in the cloud world, we must define apps to do those things and to not be too expensive to run, because pricing is usage-based. So you got to have a basic grasp of how pricing works. Do that. Windows Azure charges between 5 cents and 96 cents an hour for each role instance, depending on its size. You can have various numbers of cores and memory sizes in your VMs. You pay based on size. And now, this is a key point. You're paying per hour. You are paying per wall clock hour. If I've got an instance running for an hour and it has 100 users in that hour, or it has no users at all, it's the same price. Because you are, in essence, renting cores and memory on a server in Microsoft's data center. So it's wall clock time. For data, Windows Azure blobs and tables are pretty cheap. 15 cents per gig per month, and a penny for each 10,000 operations, reads, writes, things like that. SQL Azure, relational data, is a bit more. It's $10 per gigabyte per month. You're thinking, well, wait, why is that so much more? The answer, of course, is that you're not paying for just the disk space. You're paying for the relational processing on top. It's the difference between your OS file system and SQL Server on premises. Windows Azure storage is analogous to the OS file system. SQL Azure, analogous to SQL Server. But $10 per month per gigabyte for this platform that doesn't require the same level of admin as an on-premises platform, it's attractive for at least some scenarios. And the third big component, bandwidth. You pay per gigabyte of data moved in and out of Windows Azure data centers. 10 cents in, 15 cents out, a little bit more in Asia Pacific, because bandwidth costs more in that part of the world. You got to understand here, you're paying for gigabytes moved in and out of an Azure data center. You do not pay for data transferred inside the data center. So, an app running on Windows Azure that accesses SQL Azure data in the same data center will not be charged bandwidth. An app running on Azure accessing data on premises in SQL Server will be charged bandwidth. The cost is for data moved in and out of your data center. All right. Let's end here by discussing some scenarios. Is Azure right for every app? Oh, probably not. But it's right for a lot of apps. It's a good fit, I think, for lots of different things. Again, I would encourage you not to think of Azure as being primarily a platform designed to take existing Windows Server apps and run them unchanged in the cloud. It's not what it's really about. It's about, in the main, new code, whether it's new apps entirely or apps in the cloud that extend on-premises apps. So with that in mind, if you're building a new app or extending an existing app, and your problem has any of these characteristics, I would encourage you to think about Azure as a good choice. Number one, massive scale. One of Azure's primary goals was supporting Microsoft's own web services. They aren't built there yet, but they will be. And so it's designed for massive scale. You want to build the next Facebook? Reasonable foundation. It's also designed for high reliability. We discussed this. The Fabric controller, for example, by maintaining updates beneath a running app. I didn't tell you this, but the Fabric controller can also be used to update a running app in place. So an app need never go down, even for updates. That's a key thing. If you're an ISV who wants to build a SaaS application, well, gee, SaaS applications had better be awfully darn reliable. Brief digression here. People who build packaged apps, ISVs, face a new world because the SaaS world is just different in so many ways. The business model is different, a lot of changes. But in terms of sheer scale and reliability, if I'm an ISV and I build a packaged app, and my app runs on a Windows Server machine in my customer data center, if it goes down, that customer's unhappy. We restart it, they're happy again. If I have a SaaS app, by contrast, SaaS apps are commonly multi-tenant, which means the same software is being used by all my customers. If it goes down, all of my customers are unhappy. The requirements for reliability are much higher. And so, platforms like Azure are designed to support those kinds of requirements. So, if you're an ISV who wants to build a SaaS app, I would suggest Azure is a reasonable thing to look at as a potential foundation. Apps with variable load. This is a classic cloud platform scenario. I know a guy in New Zealand who's building an application, an online app, to sell tickets to sporting events, concerts, and so on. Think about that app's load profile. Most of the time it looks like this. Then tickets go on sale for Lady Gaga. I don't know. Who likes Lady Gaga? Don't be ashamed. Come on. Thank you. Thank you. I'm a huge Lady Gaga fan. My 7-year-old daughter loves Lady Gaga in a very constrained way. No videos, just some of the songs. Okay? So I'm a big fan. So Lady Gaga tickets go on sale. And the app's load goes like this for an hour, for 2 hours, until the show is sold out, as of course it will be very soon. Then it drops back to this. How do you provision a data center for an app like that? Well, option one, buy enough physical servers for the peak. You could do that. But if you do, you spent all this money on servers that sit empty most of the time. Very expensive. Option number two, use a cloud platform. You can spin up instances on Azure, for example, when you need them for the peak, and then shut them down. You pay for what you use and nothing more. Those kinds of spiky apps with variable load can be very attractive for platforms like Azure. What else? Apps with a short or unknown lifetime. In Paris, a little while ago, I met with a web agency that does online campaigns. They build websites for marketing campaigns. When they build a campaign, they never know how long it will last, how popular it's going to be. If it's a big success, it has lots of users and lasts for a year or two. If it's a total failure, it goes away after a month. Another great cloud platform scenario. Because you can just put it out there. There's no commitment to servers. When you're done, stop paying. You've got to grow, grow. The flexibility, the pay-as-you-go model, the no-commitment model that's inherent in a platform like Azure is a very good fit for that kind of app. Hey, by the way, are you noticing something here? These characteristics are not necessarily about technology. They're about money. Very often, the reasons to build on a cloud platform like Azure are economic, not technical. That's a key point to understand. What else? Parallel processing. In the financial world, it's fairly common to do these things called Monte Carlo simulations, where you take, for example, the price of a bond and compute that price over 10 years, given a set of assumptions about interest rates. If you do a whole bunch of those, you can then simulate what's going to happen in the future through various paths, then combine the results to estimate the likely reality. Well, doing that requires lots of processing power. Without Azure, you buy a cluster. You buy a bunch of physical servers and maintain and manage them. With Azure, you spin up the VMs, say worker roles, you use them, you pay for them, you shut them down. It democratizes access. to that kind of parallel processing. It's very interesting. What else? Startups. Startups. What do most startups do? Answer, they fail. Most startups fail, right? The great thing about cloud platforms is they let startups fail really fast. Because failing really fast means you fail really cheaply, and thus have more money left over for your next stupid idea. Or your next brilliant idea, whatever. The point is that cloud platforms are great for startups. You can try things out. If it crashes and burns, no big investment. But if you succeed, then what must you do? You scale fast. Fail fast or scale fast. The mantra for startups. It's a perfect match for cloud platforms. And just to be clear here, I do not mean just Silicon Valley venture capital style startups. No. First of all, cloud platforms make it possible to do startups with much less capital. Secondly, don't even big organizations have things that act like startups inside them? If not, they should. So this notion applies quite well, I think, to all kinds of organizations. Here's another scenario in which I have seen people apply Azure. For apps that just don't fit well in a firm's data center. Have you heard this? I've heard this. I've heard that there are some organizations in which the business people and the IT people don't always get along. Have you heard that? Not in your firm, I'm sure, but in some companies it's like this. Okay? And so one attraction of cloud platforms for some number of business units is they can build and deploy apps without having to wait for IT to roll out servers or VMs. Even better, they can build and deploy apps and never even tell their IT people. This is really attractive for lots of businesses. And by the way, if you're thinking, well, in my IT department, we'll never allow that. My CIO will stop that. Really? Really? We work for them, remember? By them, I mean the business people. You cannot stop this. What you can do, get out ahead of it. But you can't stop it. That is the single biggest reason that I see business people want to deploy cloud platforms. So, again, do not look at this and say, oh, technically, what's my motivation here? The motivations for using this, in my experience, most often the driving ones are not about the technology. One more thing here. You might just do external storage. You might do backups as blobs, for instance. What I have found is people have to build trust. And not infrequently, they will start building trust by doing backups to blobs, for example. It looks like this. Maybe you have blob data or SQLized data in the cloud. You've got to build trust at some level. And then maybe, if you want to build an app that's very scalable on the public internet, it might have just web roles. You might use tables, that very scalable NoSQL solution for storing data. Or you might build an app that's really scalable with web roles and worker roles and queues in between and all kinds of stuff. Or you might build an ordinary enterprise app with web roles in the cloud and SQL Azure. You might do this because it's just faster than waiting for your IT guys to roll out a server or VM for you. Or you might do this. You might build an app that runs partly in the cloud and accesses data on premises. Maybe through Service Bus, it's not required, but maybe. Or, as I mentioned before, you might do an app that does parallel processing, exploiting the availability of, let's say, worker roles by the hour in the cloud. In fact, today, Microsoft's Windows HPC server has built-in support for doing that. If that interests you, I'm doing a session on Thursday afternoon that's an intro, same kind of talk as this, an intro to Windows HPC server that will talk a bit about this and other things you can do with that cluster technology. It's interesting. Cloud platforms are here. Microsoft, as you can probably discern, is spending a lot of money on this. They are placing a really big bet on Windows Azure and the cloud in general. It's evident they're serious about this. My perspective here, the last thought, is this. There is, in fact, this new world unfolding. And our challenge is to work out how best to be part of this world. I said more than an hour ago that I believe cloud platforms represent the emergence of the sixth platform type. After what? Mainframes, minis, PCs, servers, mobile phones. Cloud platforms are the sixth, by my reckoning. Now think about that. The sixth platform type in 50 years. That's how old our industry is, about 50 years. This kind of change happens so rarely, so seldom. But it's happening right now. Well, we're alive and active in the industry. Aren't we lucky? It is a great time to be alive. Thank you.